All right, I think we are live. Hi everyone, my name is Aziz and I'm here from eAfterWork. It's another week, so we have another topic and a new guest to talk about a new topic around AI, sovereign AI, technology, and everything. Today we're going to talk about an important topic, which is the observability, monitoring, meta monitoring. We're going to define all those words, so if you don't know them, it's all right. Before going into presenting Itamar and starting the topic, I'm just gonna present you with the topics that we that passed and the coming ones. So the last week we had an interesting topic about sovereign AI and inference with Sufyan from Sambanova. We had the chance to talk about the inference and how they are building hardware and software and uh, allowing users to use this on premise to have their sovereign inference in place, which was an interesting topic. So if you want to check it out, you can go on my profile and you can see that we have like 200 views, which is not bad. And in November, we have another topic around the open source observability. It's going to be in French and it's going to be with Samuel. So make sure to attend it. Today, we're going to have to talk about the Pulse, which is a meta monitoring product that is developed by Itamar. But before doing so, we're going to define what is meta monitoring. We're going to define what is observability. We're going to define all those terms and deep dive into those details and take advantage of the presence of Itamar today to know his side of the story and how he is building those products. Itamar, I'm going to let you know, I'm going to let you talk about yourself, present yourself in a few words, if you don't mind.
Yeah, of course. Thank you for having me. I'm glad to be hosted on this channel. We're also broadcasting on our channels as well, and happy
Yeah.
to have each and one of you join us. So my name is Itamar. I've been doing Elasticsearch and OpenSearch for quite a lot of years now. Elasticsearch, I believe, over 15 years, back when it was all Google groups and IRC channels and all of that. It's a whole different game now, but that's how long I've been doing that. And I was a user, transformed into a consultant, and then transformed into an owner of a company that provides consulting and support services for Elasticsearch, and then also OpenSearch. Once there has been the fork, we are now working with OpenSearch as well.
Great. So for the record, this is the first time I'm talking with Itamar, so this is like a conversation and live getting to know each other. I've seen that you have put Big Data Boutique in your company. So what is the difference between Big Data Boutique? Is that the consulting company that you mentioned?
Yeah. So Big Data Boutique is a company I founded a couple of years back with world-class experts providing consulting and support for bleeding-edge open source technologies. We started with Elasticsearch back when it was definitely open source, and then we also do Spark, Iceberg, Flink, ClickHouse. We did a lot of Trino back in the day when it was cool. It's less cool now. So all of those technologies that you would find in the big tech, big data situations. We work with really large companies doing lots of interesting things globally, and we just look for those interesting challenges. Now we also do Gen AI, obviously, as everybody does Gen AI, except we're able to put a couple of things in production by now. So we also have the experience around that. And Big Data Boutique is the company for consulting services. Everything that is kind of build type engagement, you have this kind of big issue with data platform. You want to build something, you want to rebuild, you want to optimize. That's Big Data Boutique. What happened, and I'm maybe jumping ahead a little bit, but what happened is that we just saw a lot of recurring patterns when we work with Elasticsearch and then OpenSearch. And then we said, okay, let's automate that. Let's provide support through an automated AI-powered tool. And that's how Pulse was born, which is what we're going to talk as well later today as well.
So would you say that you've started with observability from the beginning, or is it something that you recognized important later on down the road?
So Pulse is not really an observability tool. We'll cover that as we go, but it was born out of that need. Yeah. So if a customer calls up, like in a huge crisis, we have an Elasticsearch cluster that is kind of, crashing. We're not able to figure out what's going on. Production is down, or we're losing customers. We're draining money. and you come in and tell them, all right, show me the dashboards. I want to understand what's going on.
Mm-hmm.
You don't have it. So you find yourself during, firefighting, installing Grafana and, fine-tuning the dashboards, taking that dashboard from the Grafana dashboard marketplaces and figuring out what's missing over there, and then, doing this live. So it takes tons of time. It took us a couple of days to figure out what the issue is and stabilize. And it happened, more than once. It happens quite frequently, to be honest. And then we said, okay, instead of doing that, let's just build a tool internally that would just get us all the metrics, dashboards, everything that we need in order to do that. So when there is a firefighting engagement, we'll just plug in everything there and we'll just see everything out of the box. And then we started doing that. And then we said, okay, we have all of that information. Why don't we automate a lot of those processes that we do? And that was quite a few years ago. And then as years come by, suddenly was all this Gen AI revolution, and everything is now Gen AI and so on. And eventually, we're now able to do root cause analysis automatically. We're able to do recommendations automatically, optimizations, and all of that.
So basically, you're saying that the auto remediation is not just a fugazi word; it's a real thing. It's possible.
Yeah, it was possible before Gen AI,
Mm-hmm.
but once we have Gen AI tooling, everything just becomes so much better.
So you mentioned at the beginning that you've started your journey with Elasticsearch and then OpenSearch later on. And you put the emphasis on the open source technology. Do you think that today the companies in production should rely more on the open source products, or they can also get vendor locked in other vendors? What's your stance on that?
I think in the end of the day, it's a company policy. So we see company policies that we're not going to touch anything that is not open source. Huge American enterprises that we see that have policies like that, and we're not going to buy a support or anything from a vendor. We just run open source. It has its prices, right? You have to maintain subject matter experts in-house.
We already define that just for the folks who watch it. What is
subject matter expert? This is the team that would basically know, in this case, Elasticsearch inside out, and will be able to respond to everything that's going on, including optionally providing patches to software or vulnerabilities, issues, anything like that. Okay. Is this the right move? I don't know. I mean, big companies can definitely do that, and they have their own reasons. I used to be very religious about open source, kind of let's do good and so on. It was, 20 years ago. I was the PMC, basically the leader for the Lucene.NET project. I was also leading Lucene. So Lucene is the engine within Elasticsearch and OpenSearch and Solar as well. It's written in Java. And at some point in time, it made sense to have ports of it in .NET, in C++. There was good reasons to have that. And people were using it. People still use it, apparently. But so I was actually doing that in my free time just because it was fun. And I did more open source projects like that. I think the world today around open source is not that naive anymore. There's legit and complete economic models, business models to make this economical. Because if it doesn't make money, it's not sustainable eventually, right? And every company has its own way of doing things. And eventually, OpenSearch, being open source that it is, allows very big companies to really invest in building something that is controlled by a community. But in the end of the day, it's economic for them to do that because they can steer the product to things that make sense to them, for example, and so on.
Yeah. I got a perspective, and they want you to correct me on that if I'm wrong. I feel like the OpenSearch can compete with the other solutions out there when it comes to search. But when we go about like the other plugins above it, for example, the SIEM or the observability, I mean, the SIEM is an observability of security. But when we go with the other plugins, I feel like it's hard for this to catch up with what the vendors like Elastic are providing us with. Do you think that it's possible to build above it? And I want also you to talk about like the other solutions like ClickHouse and how you see the difference between all those solutions, and if they are really competing with each other, or it is just that we have one big chunk of the market with one of the vendors, and then the others are competing against each other in a very small chunk of the market. So what do you think?
Yeah, so I don't know if I'm an expert in the SIEM market or APM markets, but I can share, from our experience, what we see going around. Basically, Elasticsearch and OpenSearch, to that respect as well, are very solid technologies, and they're very well known, been around for over 15 years. Even OpenSearch essentially, it's, if you know Elasticsearch, you know OpenSearch, right? So OpenSearch, for all intents and purposes, is 15-year-old. And those technologies are very, very solid. You have managed services offerings. There's tons of documentation. There is Stack Overflow, questions, answers, Reddit, and so on. There's so much knowledge around it. And also, again, managed services, that it's very easy to build on top of it. Now, the biggest difference between Elasticsearch and OpenSearch is the ecosystem, or the solutions that are built on top of that. So Elastic as a company are basically made it impossible for anyone else to build on top of Elasticsearch, those kind of solutions, unless you're obviously in partnership with them. But there is no other SIEM solution on top of Elasticsearch other than Elastic SIEM. Same thing for APM, pretty much. On OpenSearch, on the other hand, again, it's the open source area. So you have Wazoo, you have for SIEM, and you have many others, which maybe I don't even know. But in the end of the day, the technology is solid. You can host it and manage it in a very well-known manner. It is very efficient in some cases, but obviously, as technology advances, things like ClickHouse, which is, 10 times more efficient, but it's not exactly a drop-in replacement. It is a little bit different, right? So for some use cases, ClickHouse would be much cheaper and easier. Is it, more understandable than OpenSearch, Elasticsearch at this point? Probably not. Will it get there? Definitely. And then Elasticsearch and OpenSearch and Lucene would have to work hard on justifying their presence, right? Optimizing aggregations, making vector search better, providing features that are, critical to that in order to survive.
Cool. So up until now, we've been talking only about like the open source and semi-open source solutions, Elastic OpenSearch and ClickHouse. What about the other proprietary solutions? If we talk about observability like Dynatrace or Datadog, where do you see them in the equation? What is your stance on those products?
So I'm not familiar with Dynatrace too much, but I have seen New Relic and Datadog quite a bit, maybe a few others. Look, they're solid. It's a SaaS offering. So, for example, as opposed to OpenSearch, Elasticsearch, ClickHouse, you cannot run this on air-gapped environments or in private clouds if you don't want to use a SaaS solution, which is it's a big difference, right? I mean, there's so many companies that need that, and it's solid technologies. I mean, they have really, really good, fast solutions for observability. We really didn't really mention OpenTelemetry so much, but OpenTelemetry being the standard pretty much nowadays, it will only become more and more common. Definitely for Kubernetes users, but regardless, they implement it well. They do everything well. Elasticsearch the same. ClickHouse just acquired a company that does OpenTelemetry. and we have OpenSearch, which implements that as well. So very solid solutions, but they're a little bit of a different offering. Do you want to run this yourself and be the owner of your monitoring platform, or are you buying that from someone who does it well?
So what would you do? Would you, for example, if you were, let's say you were a manager of a big company out there, and you have the option to either invest in a big team that will manage your open source solutions and build around them and do basically what the community offers, or will you go and redirect that budget to a proprietary solution? What would be your reasoning, your logic, and your reasoning?
A good question. I think it all boils down to personality, and my immediate reaction is to build because hey, I can just do it myself. But then there is the time to market perspective. I mean, I have 100 people in my team. I need them to do X and that by that date. If I outsource something by buying it from a vendor, or SaaS vendor, zero integration effort, like with the Datadog agent, is that going to get me faster to where I need to be? And do I have the budget for it? Is it going to cost me more? Sure. Is it going to be faster? I think also yes. Is it going to limit me? I don't know. If all you need is like really good telemetry and tracing and logging analytics, I think it will be a much better solution than anything you can build your own, especially if you're not an expert there. So I think it's a matter of situation for that specific company and also for a personality issue. I just met today with a customer that basically told me, look, all I need is a rod, right, to catch the fish. I don't need you to give me the fish, to give me the bottom lines. I need you to give me the advice on what do I need to do so I can do it myself. Are they going to be faster at shipping features? Probably not, but this is the kind of a personality. And I can tell you that we've been working with really big companies. Some companies migrated away from Datadog to Elasticsearch or to OpenSearch, and some companies did the reverse because they kind of said, I don't want to do APM myself. It's going to cost me a little bit more, but I'll just use this managed service.
So I'm going to get back to APM later on, but what I understand from what you're saying is the reason is purely economic. So you are talking about the time to market and then the investment. So it's not like the management overhead. I mean, you can always give a price to that, but it's not basically the flexibility to build. It's just the time to do what you have today. It's not like thinking about the future. It's thinking about the short-term objectives. Is that what you're saying?
A lot of times. Again, enterprises will think differently. And you have to factor in that very large companies think very different than small companies. So very large companies, enterprises, telecommunication enterprises, right? They would have dozens and hundreds of clusters in their setup, and they will hire the team to manage that. And that team will know Elasticsearch pretty well. I mean, and maybe other technologies as well. So it makes sense. It will be maybe even cheaper for them to hire a full team and even build tooling with that team instead of going for a SaaS. Other companies, like one customer that we have right now, is the definition would be a scale-up, right? It's a startup. They had a really good time until now. They basically built a product that does really well, but then they start getting a lot of business, and then they just need to ship faster than they can. So does it make sense for them to start building their they brought us in to help them to scale fast, right? Would it make sense? And that's the core of their business. Would it make sense for them to implement SIEM and APM as well, or to buy that outside, right? So that maintenance toil, I think, in some companies, for some reasons, compliance and others, they would have to keep logs and metrics inside, and then what do? Do they manage it themselves? Do they bring someone like us to manage it for them? Do they just buy tooling to help their team manage it better? And others, it's the mission critical stuff that they have. They have a catalog search based on Elasticsearch, and it powers the website. And if someone goes to look for real estate or, I don't know, shopping, whatever, if the cluster is down or slow, they're losing business. So again, do they build a team around that? Is it meaningful enough, or do they bring someone else from the outside? In the end of the day, I think it's a numbers game.
I think you've touched upon a very, very interesting metric, which is the price of the downtime. And I've seen a figure lately on LinkedIn, which is like how much it costs per an hour for a big platform that is down. I think it's in millions of dollars. How do you price that? What's the reasoning of pricing? If, for example, I know that you have an elevator pitch to pitch your product, and I think one of the things that we would put into perspective is the fact that you would allow the user to reduce the downtime, because you will be able to intervene very quickly if there is an incident, and you will have metrics and data beforehand that would allow you to diagnose a problem and be able to fix it very quickly. What is your elevator pitch, and how will you convince the client that you would know the value of their downtime?
Yeah, again, it really depends on what they do. If it's e-commerce or catalog search, it's very easy, right? Because every time that a search takes more than some KPI that they have, probably 200 milliseconds, that's the thumb rule. People will start dropping searches, and if the search does not return at all, obviously you lost business. They would know how much money they make or lose per hour, for example, and they would know that they need this kind of insurance. So they will reach out to us, basically saying, we want this kind of insurance. The elevator pitch is usually works best when you speak to customers and they actually tell you, look, we just had this downtime last week. We either don't have a support service, and apparently we need one, or we have one and it just was not functioning fast enough, well enough. And that's when they actually feel the pain. In my experience, coming into customers and telling them, look, this could happen, and please tell me how much it's going to cost you, doesn't work well until they actually feel it. What they usually feel is the maintenance story. So think about it. I mean, you probably maintain 1 or 2 clusters in your life. How much time does that consume? You come in the morning to the office. You open the Grafana dashboard that you have, or maybe Kibana monitoring if that's your drug of choice, and then you basically stare at the dashboards. You kind of have this kind of pattern, right? You go in the dashboards, you know what you're looking for. Maybe you spot something, maybe you don't, but in the end of the day, kind of a routine that you also get into a fatigue with, right? You basically see the same graphs. Maybe you miss a couple of anomalies that you couldn't identify by just skimming through that. And, slowly you'll just, sometimes keep looking at that and just say, seems like everything is fine. You'll start relying on your alerts, or maybe worse, you'll have alerts firing all the time and you'll be also in an alert fatigue. This is the real maintenance toil that we aim for, right? One is insurance, yes, to make sure that if something happens, you recover fast. That's one. But I think the pain that most customers or most people feel is the day-to-day maintenance of the cluster. Knowing when something is wrong and figuring out what is wrong, and having dashboards that actually work for you and not the other way around, and getting recommendations about, hey, you can save money here, or hey, you need to scale up here because your ingestion is larger than it was before, and things like that.
Right. So basically what you're saying is you are doing something differently than a simple operator who is there watching the screen and waiting for something to happen. What is that thing that you would do differently?
So I think actually we do exactly that,
okay,
except it's automated. So what if you were able to do it 24/7 without getting any fatigue and watching all of your clusters, all of the graphs for all of your clusters all the time without missing any beat? Basically, that's what we do. We get, like I said, this whole thing started by creating dashboards so we can see issues faster. Nowadays, the dashboards in the product that we have, Pulse, is basically, it's just a byproduct. We have great dashboards, but it's usually the last thing I show customers because it's not about the dashboards. It's about the bottom lines. So we get metrics. Those metrics get processed. We send alerts if there is an alert to be sent. And other than that, we just create a health check, health assessment. We refresh that every now and then, pretty much daily. And then whenever something happens in the cluster that requires a refresh, and then we just show you the health of your cluster over time, and you can intervene. So we're very opinionated, but you can intervene and say, I care about this, I don't care about that. And then, for example, we tell you we have a couple of items about security, for example. You have anonymous access enabled. Is this critical to the cluster? If it's publicly exposed, probably yes. Most companies that we work with don't have the clusters publicly exposed. So you don't really care about that, even if it's an anonymous access is enabled. So you can disable that. And that's basically the idea. So you get the bottom lines, you don't get fatigued, and we call you up when something requires attention.
All right. So you're basically implying that your expertise around those technologies allow you to know what to look at and what metrics to get. Is that public? Is that something that you can share? Like what you are looking at in a cluster to see if it's healthy or not?
Yeah, sure. We actually have. I'm happy to put this here as well in the link. Maybe you can put it after. But I actually recorded a whole session about that. It's OpenSearch, but it's basically most of it applies to Elasticsearch as well. And happy to do it as well. We have put that to you here in the private chat. You can definitely put it after, but it's just a video series exactly about that. But happy to go through that. But basically, you go on a cluster, the dashboards that are the most interesting, if you're actually looking through dashboards, is the nodes dashboard. You want to see how the nodes are doing. Just as a story, most of the, not most, but a lot of the inbounds that we get, a lot of the questions that we get is we have very slow queries. Our queries are slow. I don't know why. And people always jumping to do slow log, right? Slow log query analysis, all of that, which is fine. But I would say 80-90% of cases, the queries are slow, not because the queries are bad, because the cluster is under distress, because you are under provision, because there is someone hammering your cluster, because, I don't know, the disk is starting to malfunction, whatever. So it's usually something like that. And not the queries themselves. So the nodes dashboards are the most important. And the graph that I immediately go and look for is the load average for the data nodes. So this is really the most interesting metric. If you have an 8-core data node, and that data node has 8 cores, you expect to see the load average for that node anywhere below 8, right, in general. We recommend to be at about 70-80% of that to allow for some spikes and not to be over provisioned, right? So basically, you definitely need to have enough cores for the load average when it's on the maximum. It's still below the number of cores that you have. Otherwise, you will feel distress. What do you do when you have really, different usage patterns during night, during day? We can talk about scale out. We can talk about auto scaling. We can talk about a lot of things. But in the end of the day, this is the most interesting metric. From there, everything else follows, right? Okay, there is a stress. Is this because of writes? Is this because of reads? Is this because of slow queries? And then we can look at the queries and understand why they're slow and so on.
So basically, you're going from the low level and getting the system metrics, and then you're going up until the application layer. Is that safe to say?
Yeah. I want to see where the bottleneck is,
Mm-hmm.
and then take it from there. And if there is no bottleneck, let's save you some money.
And so that brings us to another interesting topic, which is the sampling. Do you get all the metrics that you have at your disposal? Do you get all the logs you have at your disposal, or are you making some kind of a sampling strategy to like optimize, the storage? I believe that you are also billing based on the storage of the client on your solution. So how do you go around this? How do you sample? Do you get everything at your disposal? I wanted you to explain, and probably you would want to share the slide about the product here and the pricing. I've seen that you have pricing by node. So I believe
not by node, but that was exactly what I was about to respond to you with. So basically, when you talk about observability, you talk about the data ingested, right? So that's, I don't know, how Datadog and New Relic and everyone else do pricing. This is how you basically, the amount of data that you pull into. And when we talk about observability and open telemetry platforms, sampling is super important, because most of the time the system works well, and all you need to do is understand patterns. And it doesn't matter if you get 1,000 of those requests or 1 million of those requests, if they all look the same. And then you can, get patterns from that. And obviously, there's a huge difference between 1,000 and 1 million, and then you can fine tune the sampling, and obviously all errors go through, so you don't miss on any error. So that's sampling and observability and open telemetry, for those who are not aware of it. What we do is we have some logic and some brains in our agent. So we built our own agent. We're SOC 2 compliant. The agent is safe and secure. You install the agent on your premises, wherever your cluster is. If it's on Elastic Cloud, you install it somewhere with Elastic Cloud access, and you give the agent the coordinates for your cluster and the credentials for a monitoring-only user. We don't want to have any access to your data, any access to anything else that is not interesting to us, like, I don't know, passwords or anything like that. And we don't want to be able to make actions. We're not proactive in that way for a good reason. Although we do have some customers asking for that, we don't want that. At least not at that point of the life. We will tell you what to do, and I'll show that to you. But we're not going to do it for you unless you want one of our team to jump on a call and kind of, I don't know, be your buddy and look over your shoulder when you do that. So the agent does a lot of smart things, but we don't really need sampling on that end. So the agent will pull various endpoints like node stats, index stats, cluster health, and others. And it will do that in a smart way. So node stats, like I said, it's important for us. We're going to pull that every 10 seconds. Mm-hmm. Other things, we're not going to pull too frequently, so not to overload the cluster, because the data hasn't changed a lot, because it doesn't matter to us. If it's if the resolution, it doesn't need to be that high. And then on our side, we do a lot of smart things as well, right? So like you mentioned, if we are to support many customers, many clusters, it needs to be economical for us as well. So we are doing a lot of things. We obviously ingest a lot of data coming in, but when we keep it for the long term, it's not going to be kept at a 10-second resolution. We're going to scale it down. It's not sampling, but we do what you would probably know as roll-up in Elasticsearch. So we do something similar. We have a lot of brains and interesting stuff that we do over there. The pricing on our end is not on data ingested, although there is a huge difference between a 20-node cluster with thousands of indexes and a 3-node cluster with 5, or 10-node cluster with 50 indexes. There's a huge difference, and the shards are just bombarding us with information a lot of times. But we don't price based on that. We look at already the other way. I mean, how much value do we give you, and how much the risk do we do? So how much the risking do we do for your team, and how much work we take off of their plate. And that's why we price this based on number of clusters. Very simple. Where we don't price this based on node. We price this based on the size tier of the cluster. So anything below 5 data nodes, it's a small cluster. It's cheap, right? Everything above 5 data nodes starts to be real. Medium, we call this a medium-sized cluster. Up to 25 data nodes, usually this is a medium tier cluster. 25 and above, every 25 nodes basically is another tier for us, and then the price goes up at about 30%. And that comes in three tiers, right? There's essentials, so it's just the platform, which gives a lot. The second one is expert backed, so we call this premium. Some additional features, but mostly our experts are available 24/7 for any ad hoc question, but without an SLA. So you ask a question, you'll get an answer. And it can be anything from support to consulting, as long as it's not build type services, right? Anything that is build, I need you to integrate to help me install a SIEM cluster or integrate this, do that. It's probably going to fall into build, and we're going to treat it differently. And then the 24/7 SLA on top of that.
Yeah, so basically you're saying you have categories of products, and you're putting the client into one of the categories or one of the buckets, and you're pricing them based on that.
Yeah,
Aren't you taking the risk there? For example, I can have a small startup, but the team is not mature enough, and they have created indices with shards that have more than 100 gigabytes of data. It's a small cluster. You price it for a small company, but then you end up with big problems that you didn't anticipate. How are you mitigating those kind of risks?
Yeah, so I think the people who would benefit the most from our product and will actually pay for it is people with real risk in that, real risk or real pain in terms of, like I mentioned, the maintenance toil. And those would be usually enterprises or clusters, even with SMBs, or like I mentioned, scale-ups or startups that have clusters that basically sit in the core of their business. And even if they have someone in their team, they would need some additional level of support. We've seen a lot of companies that just use Elasticsearch, and it's a critical component in the system, but they don't know well enough what to do with it. We've seen tons of those. So that would be an interesting customer for the product, and they see the value. The bigger the cluster, the bigger the risk, the more reason for them to go with us. Our most interesting customers, the ones that really benefit the most from the platform, are the ones that have many clusters, usually self-managed, and they need this kind of insurance and the additional tooling and the expert support behind it. So they know that if something happens, there is someone they can call immediately if they're under SLA. And even if they're not under that support tier, they still have this tool that does a lot of the work for them, and again provides them with those dashboards.
So basically, you're outsourcing the on-call and the support teams of those companies to your side. That's what you're saying.
If those companies don't have a team like that, we will provide that kind of service end to end. A lot of times, what happens is that they do have teams, but those teams are either busy with other technologies as well, so they would be happy to get some off their shoulders, even if they're Elasticsearch experts. And sometimes if they are doing just Elasticsearch day in, day out, the tool just provides them so much additional help. And I'm happy to show it as well. If you can enable the slides for a second.
I think you can go ahead. You can just click on present. Are you able to do it?
No. I'll need you to add the slide to the stage.
Okay, which one is it? Is it already on stage or?
The slide 1.
This one?
Yep.
No, it's.
No, this is no, that's never mind. I can do it here. So basically, this is the platform, Pulse AI SRE for Elasticsearch and OpenSearch. I can share that we have more technologies coming up soon, but for now it's Elasticsearch and OpenSearch. We do work with quite a handful of customers. Some are listed here, and like I mentioned, it's not what I intended to present, but it's definitely fine. Usually, customers will have a solution in place, right? No, this one. It's fine. Keep it.
Okay, is this one?
This one, yeah. All right. So this is that. We, again, like I mentioned, we have many customers running on the platform, and it's really I think it's everything we discussed, right? It's really the what we do is an AI SRE for Elasticsearch and OpenSearch, and that basically comes to say, either you have an SRE or DevOps or a platform engineering team that handles this for you, Elasticsearch experts inside your company, or you don't. If you don't, then you probably need us, because it will just make your life so much easier, and someone else will worry about your clusters and reach out to you with exact instructions on what to do at the exact time. If you do have a team, it's just going to simplify your life so much, because and I like to give this example, like the Industrial Revolution basically gave you so much more power in what you can carry. Suddenly you have engines that can, pull so much more weight and so on, and build bigger things. And then the Computer Revolution did the same thing, but for our minds, right? Essentially, you can suddenly calculate a lot more. You can do tons of other things. It completely changed the way that we do things. I'm just thinking about how banks evolved before computers to after computers. So the same thing is what everybody's talking about today is Gen AI, right? What would Gen AI do to us? And if you think about maintaining data platforms, or SRE or DevOps or platform engineering, this is exactly it. It's not about computing faster. It's about reasoning about things that you would have done manually with your mind. Now you can do it faster, and you can automate a lot of it. And that's what we do. So again, we were doing that before all the Gen AI revolution came into play, and we just had a lot of decision trees. As it turns out, when you work with Gen AI, you get so many lies, and if you have those decision trees, and if you do have this knowledge base, and you have seen a lot of tickets and issues and so on, you can create a really good, solid AI SRE system that will do it for you. So that's essentially what we're doing. And like I mentioned, and this is Pulse, and you can take it QR code and look around, and I'll also demo it in a bit. And like I mentioned, every customer or every company using Elasticsearch or OpenSearch currently has a solution. That's definitely it. But is the solution economic? Is the solution sufficient? Is it really protecting you from everything that could happen? And could you do things in a better way and make your people happier? So that's what we're here for.
Let me just get back to the SRE. How do you define this job of an SRE person? I know that it's defined by Google, but how do you see it from your perspective? And then I believe you are a team of SREs. Basically, that's what you're saying. You are selling the SRE service to other companies that can help to have their own SRE teams. So how do you define that SRE?
Yeah, so SRE and maybe platform engineering is a very broad term, right? It's not just for Elasticsearch and OpenSearch. But what it does is a team of people that build platforms that are designed and built to sustain. They're also monitoring and handling any cases of those systems when they break, and they harden that, and so on. So it's not about just a reactive approach, but it's a role. It's a very proactive, and it's a role that should be around designing things to work also when they fail. So this is really what an SRE is. What we're building I would say it's an SRE, AI SRE, for Elasticsearch and OpenSearch specifically. We don't do anything else. We don't do Kubernetes. We don't do anything else. There's other tools out there. We do specifically Elasticsearch and OpenSearch because we know those technologies are very hard to maintain right at scale. And we're also speaking to many companies which have dozens and hundreds and even thousands of clusters. And how do you maintain that? So going to a Grafana dashboard and clicking through all of those and getting alerts done and so on, that's fine. But what if we could have grouped a lot of clusters together and see patterns and give you the health assessment, which if you can switch the screen, I'll show that how it looks like. There is my screen and not the slides.
Is this one?
Yeah, I can take it from here. Can you? Yeah. Cool. So basically, it looks like this. This is Pulse. You can connect as many Elasticsearch and OpenSearch clusters as you want. Once you have more than 5 clusters, you're going to see some sort of a bar at the top that will let you sort through clusters. We've just added a feature that lets you group clusters into sort of folders. So you can basically say all clusters that belong to this department or to this tenant or anything like that, you can group them together. And the whole premise is to, if you notice, we're not showing the cluster health, for example. I don't care about the cluster health. Is it yellow or green or red? If the cluster is red, you're going to see an alert here because it says something. There is something that you need to act on. Or if it's yellow, the same, just with a much bigger threshold. But I don't care if the cluster is yellow or red. I care about the health assessment for it. And if you click on the health assessment, you're going to see that we're looking at 4 pillars: stability, performance, resiliency, and security. And then we do a lot of checks here. And then, for example, if the indexes are not even, we're going to tell you why, which ones, and why are they not even. So basically, there is an index pattern, and the index pattern has indexes under it that are not even. And then we're going to tell you that you want to migrate this index from daily indices to rollover in this case, because we think it makes sense. If it's daily and it's uneven, you definitely want to do that. If it was even, by the way, we would still recommend that because you still want to do that. It's a best practice, but it would just not be highlighted as a warning or as a relatively high severity. It will be basically lower severity. So all of those checks will formulate some sort of a score. And if you have dozens of clusters, you can just see the scores and you can just understand which one went through a degradation, like you see here. So you can see the history. So you can see some degradation. And that degradation will tell you, what happened and why and what you can do with it and so on. Now, for example, I mentioned security before. You can go to one of those checks and you can just say, I don't know, the course is enabled, I did it on purpose, everything is fine, I know why I did it, and then you can go and ignore the check. And then basically, look, the score is fine. You can look at the score, you can say, this score is fine for me, I know what I'm doing, 70 is fine, all I need to monitor is that it doesn't degrade. But what we did even more than that. We can get you to get that to 100. So if you go and implement the recommendations, so you can see all the recommendations here, set high refresh rate on large indexes. So we tell you what exactly command you need to run. You can do this on CRL, of course, and then you can go and create a ticket directly to your team to implement it. Once it's implemented, it will be automatically resolved. So you can see all the ones that have been resolved. And then, once it's resolved, if it affects a health assessment check, your health assessment will go up. So you need to go and implement whatever we're recommending. However, if you think that you don't need to, you're happy with what that means, you can go and ignore the check. Once you ignore the check, we basically help you to get to 100 score. And then on large scale, when you have hundreds or thousands of clusters, it's going to be easier for you to track what's going on, because you can just look for the greens or the yellows and so on. So that's that.
Yeah. So basically, you're going with the topic as a hub of all the problems and the solutions, and you have those checkpoints that are dynamic. And each time you're adding a checkpoint based on your experience of all the clusters or all the clients that you have, and you're basically giving a score to the client so that if they think that what you are flagging as a problem is a false positive for them, that they can flag it out and improve their score and see the health of the infrastructure. Yeah, that's very interesting. I see that you have like OpenSearch now and Elastic, and there is something that I've seen lately going on, which is the Cribble platform, which is basically giving the clients the possibility to connect any source with any destination, etc. Are you going to do the same thing here? Are you going to allow all the other platforms to go here? For example, if I have, let's say that I'm a production team that I have many products, do you have this in mind to give the? Are you production oriented, or what is it exactly that you're trying to or are you platform engineer oriented? What is your premise?
Yeah. So we're going to add more technologies here. We can meet and talk about them when we add them. The concept of what this platform does is it's a platform essentially. So Elasticsearch and OpenSearch we support right now. By the way, this integration wizard, you can see everything that we support. OpenSearch, Elasticsearch, Amazon OpenSearch, and Elasticsearch. So basically, it's Amazon OpenSearch service, and then Elasticsearch older versions are still running on it. So we support it. We support Elastic Cloud. Then we ask you to fill in the cloud ID. And this is a homage for the old versions of Elasticsearch. So we also actually have customers running Elasticsearch 1 point something and 2 point something, and they're using the platform and they get tons of value from it. We keep urging them to upgrade, but it's not that easy sometimes. So we have that. We're also allowing to allowing to monitor Kibana. So in a lot of our customers' platforms, Kibana is a critical component. So we also allow that. And since you asked, I'll also tell you that in about just a few weeks, we're going to release log/stash monitoring. So a lot of our customers have fleets essentially of log/stash instances. It's not really clusters, but it's more fleets of log/stash instances with pipelines and everything. And we're going to release all the product features for that as well. So basically,
how is that different than the regular monitoring that you can do through an Elastic cluster, a regular one?
You do have it, but think about all the insights that we are able to provide for Elasticsearch. We'll also be able to provide it for log/stash. Yes, it's less interesting, but it could still be interesting in cases. For example, I don't know, a pipeline has degraded once its configuration has changed. We can tell you that. Instead of you looking at dashboards, we'll just tell you that. And that's what we do, right? And just to give you an example, this is our main screen. For the overview, let me quickly refresh it because I did expect something else. Seems to not work. So this is the AI summary. You should have seen here, demos will always fail. You should have seen here the AI summary of how your cluster is doing. Basically, it's going to write to you, the cluster is doing this and that. I'm happy with it. I'm not happy with it. Let's look, maybe the other one. It doesn't work. Interesting. But basically, we show you all the interesting metrics, and you can look at that over time. So if the cluster was connected to the platform 3 months ago, you just see how it's been going for it since it was connected. So, same number of nodes, documents, and suddenly there's a drop in indexing rate, for example. So you can actually see and you can pick and choose, any of those metrics, all of those core metrics, basically, that you'll be monitoring holistically. So you can see that all here, and that's that. Then we're telling you if there's any unresolved alerts, any repeating alerts. And that's where it starts to be interesting, because a repeating alert will actually have something, it will mean something, right? If you have a repeating alert. Now, remember, this is a kind of a demonstration cluster. It's not a real workload. So there will be some weird stuff here and there, but this is something we see a lot. So an alert that keeps occurring, right? And you would want to somehow figure out how to fix it. So if we go to events and alerts, you're basically going to see the alert timeline. So you're going to see, in this case, high search queue, sometimes multiple nodes, sometimes specific node has been recurring. This is Elastic. This is OpenSearch. If we look at OpenSearch in this case, you're going to see like a little bit of a different behavior. And then if you have a lot of alerts, you're going to be able to filter them. And then those alerts will get you a lot of information. So again, let's look at the high search queue, for example. If I'm going to click on one of them, you're going to basically see everything I have to say about that alert. So high search queue or node, search queue is accumulating, and it tells you exactly what happened and what is the impact, and then any next steps that we recommend to do. So for example, if we think there is a reason, if we have a reason to believe there is high long-running tasks, and I don't know, a search queue or search task that is running for a long time, will actually highlight there to you and tell you to kill it. Sometimes we're able to see it ourselves. Sometimes it's a more generic idea, but this is the idea. So we're going to give you, we call those action blocks, and it will explain what needs to be done, and then demonstrate on how to do it.
Yeah. So basically, the way you differ from, like, let's say, an ordinary observability platform is the way you leverage and use the data that you collect. It's not just dashboarding, but it's actually analyzing what's in it in an automatic way, and GenAI, using the GenAI tools, or even using the other people and humans behind the scenes, so that you can leverage something that is more of a consulting mode, suggesting the solutions, and not only reading the dashboards and the laying them out.
Yeah. So I don't know if you noticed, I'm speaking about the platform for, I don't know, 10 minutes now. Yeah. And I didn't mention the word dashboards even once. Yeah. We have dashboards. We have the best dashboards out there for Elasticsearch. I can promise you that. But it's not what we sell. What we sell is this kind of, you as an SRE, if you had a high search queue and somebody would call you up and tell you, I need you to look at that, everything you see here is what you would have been going to do manually. So we did it automatically for you. We actually identified what's going on and what is the impact, and then we tell you, what are your options. Now, sometimes we'll be able to tell you this is the right option, but as you know, sometimes there's different options and you need to choose. For example, I don't know, low disk space. Do you remove all data, or do you make a bigger disk or add another node? I mean, it's a decision you have to make. We'll show you what we think needs to happen, and then you can make up your mind. But we'll give you all the context. So that's that. So, and speaking about dashboards, we have those dashboards. So this is OpenSearch, cluster nodes, indices, KNN, shards, and queries. On Elasticsearch, we don't have KNN, unfortunately. There's no dedicated API for that. So we cannot monitor vector search performance. It's just a standard query in Elasticsearch. And OpenSearch actually does it a little bit better on that front. And on nodes, as you can expect, we basically can see, all the nodes, every information you can have. We have a metric of our own. It's called write pressure and search pressure. It's basically a calculated metric. It's one of those things that we do. It's a calculated metric that tells you if there's been any point in time that the search pressure per node has been very high. You can see that the ultra warm here node is actually the ones that's been peaking. So the pressure on the ultra warm, the searchable snapshots on Amazon, this is the ultra warm nodes, has been peaking, and you basically can see everything. So as opposed to Kibana monitoring, you can see all nodes in one place, right? We also provide this kind of cool functionality, so you can enlarge that. You can kind of dig into any. You can immediately add filters. Again, the best dashboards you can find for Elasticsearch, OpenSearch, machine stats, network, everything you can think of basically is here. We have a lot of nice tricks. For example, the load average. How many times did you want to quickly switch between 1 minute, 5 minute, 15 minute? So we have it here quite easily. So you don't have to make any changes over there. Same thing for, I don't know, caches. We do a similar thing. So by default, we show the ratio because this is what's important. hit miss ratio, and you can see, hit miss ratio of 2% is quite bad, right? But you can actually see how it looks like. So it's a derivative, obviously. Same thing for request cache and field data and all of that. So those are the nodes. Similarly, on indices, we also have a couple of nice things that we do. So what we do automatically, we group all indexes by an index pattern. So you can quickly sort, sort and change the sorting based on any metric on the index pattern level. So you basically can quickly understand the behavior pattern, right? I mean, what do I do with this cluster? Okay, I'm indexing a lot of, I'm ingesting a lot of logs to this one and less to this one, and then it goes down from here. Or I'm searching which ones I'm searching more. So very easy to understand that. And obviously, you can quickly know the specific indexes as well. Yeah, so we have that. All of those are the ones. We automatically group all the internal indexes, so you don't have to care about them, and then all the indexes that are not within any pattern, and all of this is identified automatically. So it's not something you need to configure.
Indeed, those are good dashboards. What is the time series database they use behind the scenes? If you can tell us, what is it?
You'd have to guess.
I believe it should be something around Elasticsearch or OpenSearch.
It is Elasticsearch. We thought about moving to clickers at one point, but Elasticsearch just works great for us at this point.
That's great. I mean, the latency is so great. You can see everything. Yeah, those are great dashboards indeed. It was not a bold statement.
So I didn't show everything. So we have a heat map or a tree map here. So you can quite easily zoom into so you choose which metric you want to sort this by. And sometimes visually it's easier to kind of, understand which one in terms of search takes the most heat, right? Or if you want to sort this by storage space, you can see that you have two patterns that are basically, equivalent. And then it's sometimes very easy to look at it this way. So we have that. We have shard heat maps. So you can see the non-tiered nodes and the ultra nodes in this case, and you can kind of understand. You were showing if there's any imbalance in terms of search, or if there's an imbalance in terms of indexing, which we do. It's kind of expected, to be honest, but you can see that. And then this is on the nodes level, and then you can quickly jump to the indices level and see, which shard is the offender in this case. So, for example, here quite easily you can see from this graph that maybe this specific index needs to have more shards, more primary shards, because it would balance the writes better, right? So this kind of thing you can see visually very quickly. And then obviously the platform would create this kind of recommendation automatically, because again, if you can see it visually, you can describe it also programmatically. So we have that. I mentioned KNN dashboards. The same thing is for Elasticsearch as well, except from KNN. We do have a query analytics feature. It's not enabled on those clusters, unfortunately. But out of the box, you're going to get, maybe we will see a couple. Out of the box, you are going to see the slowest queries that we automatically detect. You don't have it right now. And we call this sampling mode. So basically, you will see the actual slow queries for any query that takes above 30 seconds. I think it's a decent threshold. And we're sampling that and to show you the queries that are slow and 30 seconds or more. Yeah. There is a way to basically ship all the queries to us. And then we're also able to do fingerprinting. So basically automatically understand which queries belong to the same family of queries because they were created or generated by the same code or screen. And then based on that, tell you what would be our recommendation for it. Maybe the Elastic, I think we don't have it on those clusters, but we have a couple of customers who have been using it and we're able to find quite interesting patterns. And so again, those are things that I don't think anybody offers anywhere, and we do have it. So unfortunately, I cannot demonstrate it right now. But again, you'll see the slow queries. You can see the full list as well, and then you actually be able to see the fingerprint and any insights that we have on that query or that query family of queries.
Yeah, there is something that you passed on, which is the cost optimizer. That's an important one.
Yeah, you talked about pains and not about cost.
Yeah.
So the cost optimizer essentially is, we're on the Elastic side now. A cost optimizer basically is, to us, it's another view of the same data, right? So on the health assessment, I'm looking at stability, performance, resiliency, and security, because that is the maintenance toil. That is where the risk is. That is where you would want to get, let's say, significant understanding of how your cluster is operating and how to improve that for either your teams or your customers. Cost is a lot of recommendations we're going to get you around stability and performance are going to be the same, but also we could be able to affect performance. So for example, indices sizes are even. If we are going to have a recommendation about moving to data streams, and it also relates to some extent also to cost. So when you go to the cost optimizer, we're going to basically automatically generate the current cost, and with an asterisk. We don't really know what your cost is, but we can estimate, right? We can see how many cores, disks, memory, and so on. And if you're on Elastic Cloud, we know what the cost is. If you're on EC2 or any managed service, if prices are public, we're able to derive. So it's not necessarily your real price, but it's pretty close. It should be pretty close. And we're going to break this down for you, what the costs are. And then we're going to basically suggest, usually we suggest one or two different cost plans, and we give them a name. So in this case, aggressive ILM and consolidation versus some savings that are more conservative. And we're going to show that to you and basically say, we don't see a reason for you to be on an Elastic subscription that is high. And masters, you definitely can maintain what you have right now, but we recommend that you move away one hot node and move data to warm tier. So warm tier usually are cheaper, and you can do that. Keep the frozen tier. You have an ML node, you can keep it, but you can eliminate the coordinating nodes, right? And then change any storage, and then basically, we just saved you $1,000 in this case. A more conservative approach would do something a little bit different, and it will just say, in this case, I need to say the reasoning, but basically keep the coordinating nodes, but reduce them and don't do any changes to the tiers themselves. Similarly, and you can see the optimization insights here, and we can kind of show you we'll obviously go with the bigger number because it's cool. And we can, on OpenSearch, definitely running on Amazon, we can do similar things. So for example, you don't have frozen, but you have ultra warm, and obviously we look at that as well. That's the cost optimizer. One thing we are not doing at this point because it's a little bit more tricky, but we will get there. It's clusters running on Kubernetes.
Okay.
There's a lot of clusters running on Kubernetes. Elastic did a great job with this ECK, the Kubernetes operator for Elasticsearch. We are, as a team right now, working on helping OpenSearch, the Linux Foundation and OpenSearch, release a Kubernetes operator for OpenSearch, which is actually production safe and actually tested. Once we've released that, we're going to do two things. One is we're going to see more people using OpenSearch on Kubernetes as well. And we'll need to figure out how Cost Optimizer reflects that, because I don't know what your cost on Kubernetes is. Okay. But we are still talking about cost in terms of resources. So we'll need to figure that out, and we have some ideas, and we will reflect that. So when a cluster runs on Kubernetes, we know it. Yeah. And this screen will look a little bit different. And the second thing we're going to do for OpenSearch, we are going to allow smart auto-scaling through pulse. So essentially, you will be able to run OpenSearch on any Kubernetes cluster. It's open source. And the operator will be able to basically consult with Pulse if you are a subscriber of Pulse and get some instructions on how to do it. And then you can basically whitelist the operator what you allow it to do and what not. So again, this is still in very early stages, but that's also something we're going to do.
I believe Elastic, they already have that in place in their cloud offering and in their enterprise offering, if I'm not mistaken.
On the Elastic Cloud has some feature like that. I would say, and I will say that to our customers as well, I will be very, very careful with implementing autoscale for a database in general, like Elasticsearch. And if I would do autoscale up, I would limit it, and I would only downscale manually, at least for the first.
What's your reasoning? Is it like the transfer fee, the fees, or is it why?
Because it's a risk. Because if you have an automation that is based on traffic, I think you would want a human to gate the downscale, just to make sure the downscale is not done by mistake. So if you give the operator or the cloud an authorization to downscale, it could have bugs.
It may get some data loss as a consequence of like decommissioning a node that should not be decommissioned. Is that what you're saying?
Yeah, it could be under provisioned, and it will, shard movement and so on. It could be very costly to bring this up until you do, and it could be a cascading effect. I would be very hesitant. I would only fully automate that after a long period of a human gating any downscale operation.
Okay. Yeah. Well, I think we've been speaking for almost an hour and 12 minutes. Before ending this, I know that you have a great product. Congratulations on that. I don't know if you want to speak about the economics of this or not, but I have a more serious question for you, which is based on your experience and all the clients that you work with and the product that you're launching today. If you have like three advice to give to people who are managing clusters, and let's just limit them to Elasticsearch and the OpenSearch ones, what should be the three components that they need to pay attention to in order to maintain their infrastructure and be efficient about their production?
Well, it's a good question. I don't know if I have three, just from the top of my head. I would say Ngrams is probably one thing that we see a lot being overused. So you wouldn't believe how many times we fixed a cluster and we saved tons of money. There's an example of a company in Japan where we saved them, I think, $15,000 a month by just disabling Ngrams. It's crazy. And I mean, it's not that you don't need to use Ngrams, it's that you need to do it smart. And oftentimes there are actually better alternatives, or you don't need it at all. It's just, there's just some blogs out there in the internet that guide people to use Ngrams, and it's not the right choice many times. So Ngrams is definitely something I would say look out for. I would say the second one maybe is local disks. There is some risk of running on local disks on cloud, for example, but it's, the performance you can get out of it is crazy. We did see a couple of times where AWS EBS GP3 outperforms local NVMe in very unique, specific cases, but most of the times NVMe is going to be much better, much cheaper. I don't know if I have a third one from the top of my head, but there's tons of good advice on our blog.
I mean, good. Those advices are really good. Thank you very much for coming today. I'm going to ask one last question, and then we can wrap it up. Let's talk about the next session. We're going to talk about OpenTelemetry and open source. Give me your stance about OpenTelemetry today. Where are we at? Why are the companies implementing it? Even the incentive is to avoid vendor lock-in. What is your perspective on this? And that's it.
Yeah, so OpenTelemetry is an open format. You mentioned Datadog, you mentioned others, Elastic as an example as well. You would implement that and you could quite easily switch between vendors. That's true. I think most of the companies at this point do not understand the value that OpenTelemetry is able to provide, and the value is huge. So basically, if you don't know what OpenTelemetry is, go and check it out. You would be amazed in what you can get out of it in terms of observability. Like you mentioned, it's a fast-moving train, and I think you should definitely be on it.
Thank you very much. Thank you again, Itamar, for coming today and sharing your knowledge with us. And thank you for sharing your product with us. And happy to have you again in the future.
Aziz, thank you very much for inviting me. And good night to you all.
Yeah, good night to you as well. A good one. Bye.
Bye-bye.